Hello everyone, welcome. This week we're studying static methods. And this week and next week are really kind of transition weeks. We've just finished the 3 control structures, and I'll talk about that in just a second. And after the midterm, we are going to start writing our own classes, and we are going to be involved in writing more program level things than statement level things. Don't worry, you'll still be having the opportunity to write lots of statements. But this week, we are starting to collect statements. And that's what a method is a named collection of statements. And I'll get into that in just a moment. And next week, we will start to collect data in arrays. So let's figure out where we are at the moment. We just finished the 3 control structures. Like I said, those 3 control structures are sequence. That means you have to do things in the right order. And that's the one that's so simple everybody forgets it. The second one is called selection or decision. They're if statements in Java. And the third one is the looping or the repetition, which we just did last week with our loops. Theory says that anything that can be computed using those 3 control structures. Now, there are some things that can't be computed, but that's a topic for a different course. But anything, if it can be computed, it can be computed using those 3 control structures. So the immediate question is, well, why isn't the course ending now? We have everything we need theoretically to do anything that we need to do, or that we can do. And there are several reasons why, and we'll just talk about the reasons for methods today. One of them is a really hard technical reason. And let's take an example. Let's say I am writing a program that has to calculate square root a lot. Well, if I calculate the square root here and calculate it here and here and here and here and here, I have code calculating a square root spread throughout my program, which is called code bloat. And it's much more efficient to put that square root code in one spot and have everybody who needs it basically execute those commands from that one spot. So one reason we have methods is to fight code bloat. It's a more efficient use of our resources, of our memory primarily. Another reason is a software engineering kind of reason, or software design kind of reason, which is if I spread my square root code all over hither, thither, and yon, and I discover a bug in it, I have to go searching each of those places, and maybe the bug's in some places and not in other places, and it quickly becomes a mess. On the other hand, if I have it in one spot, I fix the bug in one spot and the entire program benefits from that one fix. The last reason I'll bring up is sort of a programmer sanity reason. I'm sure that you guys have already run into the phenomena of getting lost in your own program. You're doing something and you're working here and you got to do something there, but you can't remember exactly where you were here, and you're not sure that there is the right place to do it, and you're really confused about this code up here. And so it's kind of a forest and trees thing. And you've probably already run into that. Most programmers run into it very quickly. What methods will let us do is figure out how to do square root one time, and instead of keeping up with all the minutia of those statements, we package up those statements after they're debugged, and we slap a name on them, SQRT maybe, And thereafter, we don't have to worry about all those details. If we need square root in 500 places in our program, the only thing we have to remember is SQRT, and it's done. So those are some reasons why methods exist in Java, and some other languages use different terms. They may use the term function, they may use subroutine, they may use procedure. I think one language used the term signal. These are all hitting at really the same mechanism, and this mechanism has existed as far back as I know in terms of software development. I'm sure it even existed before the advent of higher level languages, such as Fortran being the first. So that's kind of where we are. We are going to start this week collecting statements and slapping a name on them. Now, the book is pretty good with this. Let me, I will in a moment go over some of the general ideas of a method call and stack frames and so forth, and the parameter correspondence. Now let me talk a little bit about the lab. In this lab, your class names and your method names are very, very important. I am going to use my software to test your software. And if we can't match up on the names, my software is going to say that your software doesn't work. So be very, very careful about the class names you use and the method names you use and the signatures you use. And those are all specified as far as they need to be specified in the lab write-up. Also, in your program, start to separate your user interface stuff from your methods, the text box strings in our case this week. No text box string method should do a system.out.print. Nothing. It should certainly not have a scanner in it and be reading from the user. All of that user interface stuff should be in your main method in that other class, not in text box. So start pulling apart your programs and isolating your user interface to one place in your whole program, even though we may have lots and lots of other classes with methods also in your program. But those two things are segregated. And that's very important, starting this week, and it will be continuing to be important throughout the rest of the course and your career. So let me try to share my screen. And there we go. We have a simplified sort of situation here. I have a main method here on the left, and it does some stuff, and it calls method 1 with actual parameters or arguments for 5 and 4. Over here, I have my definition of method 1. It takes 2 formal parameters or parameters. And in the middle, I have my call stack. And as I've just started main here, the only thing active on my call stack is my main method. Now, some terminology. In the method header, these guys, the int A and int B, are referred to as either formal parameters or parameters. There are 2 sets of terminology running around for this in computer science. It's been that way ever since I was your age. you'll eventually come to understand that programmers don't agree with anybody. And so even in the many decades since I was your age, we still have two sets of terminology, and you can use whichever one you want, but you have to be able to understand both, because another programmer is not going to agree with to use your terminology. So anyway, these guys on the method header are referred to as formal parameters, and these values in the method call are referred to as actual parameters. The other terminology is these things in the method header are called parameters, and these values in the method call are called arguments. Now, you may have wondered why we've always had public static void main string array args. That's because it's getting in the arguments from the command line, probably. But that is where that terminology comes from. That's where that variable name comes from. And last week this week we'll be talking some about scope. These formal parameters over here are really placeholders for the values of the actual parameters, and their scope is the body of the method. Scope is incredibly important. You'll want to have that down. The scope of a local variable is from the point of its declaration through the end of the block in which it is declared, so you'll want to understand that. This thing is on the call stack. It's a call stack because it's going to record who's calling who at this instant. And at this instant, well, I'm executing main and it hasn't called anyone. It's called a stack because that's a very important data structure in computer science. If any of you are business people and understand about inventory, you may understand a last in, first out inventory scheme. That is exactly what's going on here with a stack. It is a last in, first out data manipulation mechanism. Very efficient, very, very efficient. So we're executing this main here, and we hit this meth1 call. And so we are going to call meth1, and part of calling meth1 is putting meth1 at the top of the call stack. And this main down here is still there, but it's sort of suspended. It's not executing at this moment. Meth1 is at the top of the call stack. That's the only thing that can execute. And I copy the values of my actual parameters here into their formal parameter placeholders. And you'll notice this is done by position. The first actual parameter here is copied into the first formal parameter here. The second actual parameter here is copied into the second formal parameter placeholder here. And meth1 can execute, do some things. And you'll notice that I'm copying values here. Java is a call by value language. Other languages, you may use different parameter passing mechanisms, but Java uses call by value. And that's, again, very, very important and subtle. The section 6.5 has an animation talking about some of the subtleties of call by value. I highly recommend it to you. So over here, meth1 executes, that's fine, it finishes, and we're going to return. Now notice meth1 does not know who called it, and it doesn't care who called it, okay? Java keeps up with all that. Java keeps up with the fact in here, actually, that it was called from this particular location in the main method. And when meth1 returns, Java is going to return it to the next thing that ought to execute here in the main method. So let's look at what happens there. I return, you'll see this is called a stack frame, these entries into the call stack. And you'll see that the meth1 stack frame is gone. Meth1 is no longer executing. Main is now at the top of my call stack, and I'm executing this stuff. So I go down, keep going down in my main, and I set an integer a to 3 and an integer b to 2, and I call meth1 again. And so, like the other time, here I'm going to transfer control to meth1. There is a new stack frame at the top of my call stack for meth1. But now look at these parameter names. B is my first parameter here, but its value, which is 2, is copied into the first formal parameter for meth1, even though it's A. So actual parameter B is the value is copied into formal parameter A because B is the first actual parameter, A is the first formal parameter. A, the second actual parameter here, that value is copied into the second formal parameter placeholders. These formal parameters are for meth1. And so I can go do my calculations here. Since the formal parameter A was given the value 2, this is going to be 2 minus, and the value for B that was the formal parameter B was the actual parameter A, which was 3. So this is going to be 2 minus 3 here. And then I'll eventually return. This call stack is popped, and it will revert back to this particular call stack with main at the top. The main method will keep processing down here, and meth1 is just sitting there. Some other things that you really want to pay attention to in the text are that signature is very, very important, because if we are overloading methods, if I have another meth1 here, the signature is the method name and the types of parameters. So meth1 signature int is this method. If I had a meth1 with a string, single string formal parameter, that would be a different signature. And as we're doing our lab this week, you'll notice each of those text box methods, text box string methods, have a different signature. And that's how Java knows to associate calls over here to which method over here we really want to invoke. So signature is incredibly important. I think that's really about all. I think in terms of the minutia, the book does a really good job. I just wanted to give sort of a high-level overview of what's going on and to talk about the calling mechanism and how the parameter copying is done. And again, understand section 6.5 when it talks about call by value. It's got a really great animation, but you're going to have to do some work to understand it. So that's all I have so far. We've talked about where we are in the course. We've just finished our 3 control structures, and we're now starting to group statements. Next week, we'll start grouping data. And we've talked about the why do we have methods, and I won't belabor those again. And I talked some about the lab and what's important there and how you don't want to go just mixing user interface in everywhere. You want to segregate that into the main method and not have it in your text box strings methods at all. You really need to have two different classes for this lab. That's very important. By the time the course is over, you will be writing programs with many classes in them and many files. Each of those files should be in its own file. Each of those classes should be public, which means they'll have to be in their own files. So hopefully that helps. Let me know if there are problems. And things are going to start getting more fun, I think, after this. Talk to you later. Bye.